Okay, today we're going to be doing the remainder and factor theorems on worksheet 19A. A factor, if a polynomial p of x is divided by x minus r, the remainder is a constant p of r, stands for the remainder, and p of x, the polynomial, is equal to 2 of x, which is the quotient, times x minus r, which is the factor, and then the p of r part plus the remainder. That's how it can be written. Now, I've already shown you those when we divided by a factor synthetically. I showed you how to rewrite it in factored form with the remainder, which is written over the factor. So in this example, f of x equals 3x to the fourth minus 2x cubed plus 5x plus 2. Use synthetic substitution, synthetic division, to find f of x divided by x minus 4. Remembering that the factors are in the form x minus a, they wrote x minus r here. I just don't want you to confuse that with the remainder. We had said x minus a, so if the factor we're doing is x minus 4, then what would the a value be? Yeah, positive 4. Okay, so we would divide synthetically by 4. Okay, so it's going to be 4. And then the leading coefficients, 3, negative 2. Oh, I don't see an x squared term, so I use a 0 for a placeholder. Then I got a 5 for the x term and a constant of 2. So I'm getting ready to do synthetic division. So the first step in our synthetic division is drop down the first number below the bar. Multiply by what we're dividing by, 4. 4 times 3 is 12. Add vertically, we get 10. Multiply by 4. Put it under the 0, we get 40. Add, we get 40. 4 times 40 is 160. Add vertically, we get 165. And then 4 times 165, 660. And then add vertically, and we get 662. 662 is the remainder. Okay, what that means is the f of, oops, I don't want to tell you that yet. Okay, so we got 662. Now it says to find the f of 4, which means to plug 4 into the function. So if we do the f of 4, that would equal 3 times 4 to the fourth. You just type this on your calculator, minus 2 times 4 to the third, plus 5 times 4 plus 2. Okay, I'll let you guys type it in instead of me getting out my calculator. All right, after you've typed this in, I'm hoping someone's got it by now. It's 662, isn't it? Okay, so guess what? You can do synthetic division to get the f of 4. When you do synthetic division, that means the f of 4 is 662, whatever the remainder is. And that means there's a point on the graph. That would be 662. I'm thinking if we put this polynomial into our grapher, we'd have quite a window change to do, wouldn't we? To see that point. Okay, now what have we discovered? All right, is that dividing by the factor x minus 4 gave a remainder which equals the f of 4. All right, in general, this is always true. The remainder, when dividing by x minus a, it gives you the f of a. Okay, so it's kind of neat that if you don't get 0, remember if you get 0, then it was a factor that is a factor of the polynomial. If you don't get 0, the remainder is the f of a. That's what we learned. Anybody still need this? Okay, let's try another. So we're going to use synthetic division to find the f of 4, which means we're going to do 4. That would be like the factor is x minus 4, just so you know. We don't change the sign if it says to do the f of 4. You just divide by 4, okay? So we'll go 4, set up our synthetic division, 2, 1, negative 5, and 3. I just checked to make sure I didn't miss any powers of x. Drop down the 2, start multiplying and adding. 4 times 9, 36. Add vertically, you get 31. 4 times 31 is 124. And we add vertically, and you get 127. That means the f of 4 is equal to 127, which again is a point for 127 on the graph. Dividing by 4, yes, Scott? You could be asked. I want you to realize that that's a point because it's kind of important to all the notation that we've been doing all along, not just this section. So, I mean, I want you to know what this means, that this is an x value, okay? The 4 is an x, and this number is a y value. And that's why it's a point on the graph, okay? Okay, 4 goes into, now we got 3. Oh, no x squared. Put a 0 in. Negative 4 and 2. Now, remember that right when you start off looking at a synthetic division problem, if it's a cubic, you should have 4 placeholders or 4 terms, or 4 coefficients, if you will. Coefficients and a constant. All right, drop down the 3 and multiply. I get 12. Add vertically, and some of you may be ahead of me. 4 times 12, 48. Add vertically, you get 44. 4 times 44 is 156. Add vertically, is that right? No, wait, it's 176. Hello. 1600 plus 16, so 176. And then add vertically, we get 178. Of course, that means the f of 4 is 178. And again, the point on the graph would be 4, 178. I don't know. I've noticed that in some people's notes, if you were watching Mr. Hardy, I don't think that he writes down the point. I don't know. You know, it's not necessarily what in the book that you need to write the point down. I'm just wanting you to know or telling you. Okay, number 3. We're going to now do synthetic division to find the f of negative 3. So we're going to divide synthetically by negative 3. Leading coefficient of 5, a negative 4 for the x squared term. There is no x term, so we need a 0 placeholder and a constant of 2. So you may note that you're always going to have 4 terms, if one more higher term than the degree of the polynomial you start with. Drop down the 5 and start multiplying. Negative 15, add vertically, negative 19. Negative 3 times negative 19, 34, 57. Add vertically, and then what's negative 3 times 57? Negative 171. I do a lot of practice in my head, no big deal. Negative 169. All right, and so that means the f of 3, negative 3, was negative 169. And of course, that's the point. Negative 3, negative 169. All right, one more f of negative 3. got a 4th degree polynomial, so I should have 5 placeholders here. 2, -4, 3, 1, and -6, which is 5 coefficients, if you will. Drop down the 2, multiply. Add vertically, -10, and then multiply, get 30. Get 33. -3 times 33, -99, and then I add vertically, get -98. Oh dear, this is a big one. 294. Add vertically, and we get 288. So the f of -3 for this polynomial is 288. Okay, number 5. It says show that x plus 5 is a factor of x cubed plus 2x squared minus 13x plus 10. Then find the remaining factors. Well, if x plus 5 is, we're showing you that that's a factor, then the a value is -5 that we divide by synthetically, because remember the format's x minus a. The leading coefficient of the cubed term is 1, the squared 2, the 1st degree -3, and 10 for the constant. Did I do something wrong? Oh, I wrote -13 and I said -3. Thank you. Drop down the 1, multiply, at least I got the right number there. Vertically add and you get -3. Multiply and you get +15. And then you add vertically and get 2. -5 times 2 is -10. And thankfully we end up with 0 for the remainder. Which means the f of -5 is 0. Which means that this is a point, -5, 0 on the graph, which is a what? X-intercept. You should know that, okay? It's one of the zeros of the polynomial. All right, now, the reduced polynomial, we haven't talked about this in a couple days, since before the quiz. The original polynomial was a cubic. The reduced polynomial after first synthetic division, it's like dividing through by x. Therefore, this would be reduced down to not a cubic, but a quadratic. So this would be 1x squared minus 3x plus 2 would be that written out again. That's what it stands for. It's the coefficients of those terms. And then we can factor this as x minus 2 times x minus 1. And then these would be the remaining factors. Okay. Those are the remaining factors, which is what they asked for. All factors would be the factored form, and that would be x plus 5 times x minus 2 times x minus 1. That would be also called the factored form. Yep. You do need to know that, yes. Okay, so that original polynomial, x cubed plus 2x squared minus 13x plus 10 equals x plus 5 times x minus 2 times x minus 1. Okay, another example. Number 6, give a polynomial and one of its factors, given a polynomial and one of its factors, find the remaining. And write as a completely factored polynomial. You just said, do I have to know that? Yes, you do. Because you have to write, if it says to write as a completely factored polynomial, then we're going to write them all out. So we're going to have 2 answers. We're going to have the remaining factors here. A is going to be 2. So we'll divide synthetically by 2. Our coefficients are 1, 1, -10, and 8 for the constant. Bring down the 1, start multiplying, add vertically, multiply. We get down to 8 plus -8, which is 0. The reduced polynomial is x squared plus 3x minus 4, which factors to x plus 4 times x minus 1. These are okay, those are the remaining factors. Excuse me, my pen stuck. Okay, so this is the answer to what are the remaining factors. And then factored form, the factored polynomial p of x would equal x minus 2 times x plus 4 times x minus 1 in no particular order. Pardon me? From right here? And then these are from here. Okay? Okay, one of the factors is x plus 3 on number 7. So we're going to divide synthetically by a being negative 3. Leading coefficients are 1, negative 4, negative 11, and 30. I start doing my synthetic division. So I've got negative 3 times negative 7, that'd be positive 21. Add vertically, we get 10. Multiply by negative 3, get negative 30. Add vertically and get 0. See what the reduced polynomial is x squared minus 7x plus 10, which factors to x minus 5 times x minus 2. All right, now these x minus 5 and x minus 2 are the remaining factors. Oops, I can't spell. I'm missing letters. Okay, remaining factors. That's the answer to that part. And then here I can show you what the whole thing factored out. I mean, what did we start with? It was x cubed minus 4x squared minus 11x plus 30. That is equal to x plus 3, the first factor, what we started with, times the remaining factors, x minus 5 times x minus 2. Those are all the factors. Okay, these are all factors. Yes. Oh, no, I just don't want to always keep writing all that over again. I just did it to clarify for note, just for notes. No, if you're going to give me the factored form, that's all you need, that whole thing. And it is a polynomial. I usually use p of x for the polynomial. I mean, if I'm asked for all factors, just this answer is fine. Okay? You don't have to write all that out. All right, try again. A will be negative 7 for number 8. Leading coefficients 1, 15, 71, and 105. Negative 7 times 1, negative 7. 15 minus 7 or plus negative 7 would be 8. Negative 7 times 8 would be negative 56. When you add vertically, you get 15. And then negative 7 times 15 is negative 105. And you add vertically and get 0. The reduced polynomial is the squared, x squared plus 8x plus 15. And that factors to x plus 3 times x plus 5, or vice versa, which I wrote x plus 5 times x plus 3. You can see that factoring has kept going with us throughout the units. Got to know how to factor. All right, so these are the remaining factors. And what that means is there are more factors than that. It's because there's the one I started with. So factored are all factors. I guess I could write just all factors. Is x plus 7 times x plus 5 times x plus 3. Now you should also know something else about these. These factors tell you what? What would it be for the graph? all those x-intercepts, -7, -5, and -3. All right, next we're going to do our A value would be -4. We got leading coefficients of 1, -7, -26, and 72 is the constant. To bring down the 1, we get -4. -7 plus -4 is -11. -4 times -11 be +44. Add vertically, and we get 18. And -4 times 18 is -72. We get 0 for our remainder, which means x plus 4 is a factor of the polynomial, but they already told us it was. We got x squared minus 11x plus 18. We can factor that to x minus 9, x minus 2. Those are the remaining two factors. I'm just really tired of writing remaining, apparently. Okay, and then the all factors, since it asked for both, was x plus 4 times x minus 9 times x minus 2. Yes. Okay. How am I going to answer that question? If you had a remainder, okay, so let's say, and I'm not going to say there's obviously not one, right? Things are a little different. So let's say you ended up with the bottom of, you had divided by 4, and you ended up with 1, I don't know, I guess, how do I want to say this? You have a number here, okay, that's what you're saying. Then you would have to say whatever this was. So let's say this was x minus 2, okay? Then it'd have to be plus 9 over x minus 4. All right? So a remainder actually gives you, says that the thing you divided by is not a factor. Not an even factor, because you would have a remainder. So then your factored form wouldn't look like this. It would have plus some icky thing at the end. Okay? Is that, so we're, that was like the first time when we did synthetic division, I showed you if there was a remainder, then you put that part over the divisor. Okay? Okay, now I've seen 3 ways to do this problem. One way I don't like, and the other 2 I'm fine with. So I'm going to show you the 2 ways I see is the better ways to do it. Okay, another type of problem. Again, I was kind of surprised that I actually watched part of another teacher's video, and they did it so much differently than I showed it. I was kind of surprised, and I wasn't real thrilled with that method. And then I saw another teacher's method that she did it a little differently than I had done it, and I liked it, and it was fine. But I was like, well, you know, I've done it the way she did it before, and then the way I do it. But either way is good. Whatever way you like, I'm going to show you 2 different ways. Okay. So look at this problem. We got a missing variable, like a coefficient that we're trying to figure out that makes this satisfied. All right. So it's saying we're dividing by x minus 5. So that would give me an A of 5. All right. So this says the remainder is 6. And we know where that goes when we do a synthetic division. So my suggestion is that we do a synthetic division. Bless you. All right. So let's divide synthetically by 5. All right. So this is way number 1. 1, -7k, and 19. And then where's the remainder go? Yeah, way under the 19. Great. All right, so you guys are understanding this setup. We drop down the 1. We start multiplying by 5. 5 times 1 is 5. We add that with negative 7 and get negative 2. Then we multiply 5 times negative 2, put that under the k, which is negative 10. And then we add vertically, and that'd be k minus 10. Now, the next step would be multiply k minus 10 by 5. Okay. And then we would add vertically and set it equal to 6. So we'd have 19 plus 5 times k minus 10 equals 6. We're okay with that? I'm going to distribute. That'd be 5k minus 50. 19 minus 50, what's that? 31. Then we would add 31, and I'd divide by 5. So the answer is 37/5. Now, I would never have guessed that. No, it's 37. I added 31 to both sides. Okay? Okay, so the answer to k is 37/5. Now, here was another way to do it. What's the remainder come from? Doing the f of what? 5. So the f of 5 means plug 5 into the polynomial. So we could have done the following. 5 to the third minus 7 times 5 to the second plus k times 5 plus 19. And then what did we get? What did this thing equal? Well, the f of 5 equaled 6. Okay, so I'm just getting rid of this now, right? So my point was we would set the f of 5, plugging in 5, equal to the remainder 6. This gives the same result as what we just got. That's 125 minus 150, no, 175. 5 times 25 plus 5k plus 19. And if you combine your 125 minus 175, that's negative 50 plus 19. We're right back to here. Okay? Everybody understand if I combine all those numbers, I'm going to get 5k minus 31 equals 6. And blam, we got the same answer. Now, another way I saw someone do it was to go and say, well, and I'm just going to describe this, and then I'm not going to say much more about it. It went like this. And they said, what would have to go here to get a 6? Negative 13. And so this would have to be negative 13 divided by 5. Well, because 5 times that would give you negative 13. I just kind of got confused at this spot, and I just was like, well, wait a minute. 5 times negative 2, so it'd be negative 10 plus k has to equal negative 13/5. You see what I'm saying? That's how I saw someone else do it. I'm just done with that because I don't think you like it. Okay, we can do. Okay, so we'll just like remind our way we did it. All right, moving on. All right, write a polynomial function that is a double root of 2 and a root of negative 3. Oh, double root. What that does is do a bounce. Okay, bounce. All right. Double roots bounce. If triple roots go through, double roots bounce. Triples or others, odds don't. They go through. Okay, so anyway, let's see what this might look like. It says a double root of 2 and a root of negative 3. I just like to draw the picture. So if it's a double root of 2 and a root of 3, what's the degree? It's at least degree 3. That's 3 answers, right? So it's at least degree 3. Or it could be, it's got to be an odd degree though. Odd. All right, so it's like doing something like this. It's coming through, going up, and then it's coming back and it's bouncing at 2. I mean, that's just an example of what it might look like. There's tons of ways it could look. And it would all depend on what coefficient you put on it and everything. All right, so there's more than one answer possible. That's my point. So here's our polynomial. P of x would be, very simply put, x minus 2 doubled would be parentheses around it with a root power of 2. And the other one would be a root of -3, so that would give me an x factor of x plus 3. Now, technically, we should multiply this all out and everything and make a lovely polynomial. But I'm saying let's just leave it factored for now, unless it tells you got to multiply it out. Okay, your assignment is on page 380. Guess what I did? I made a worksheet with the book page on it. Okay, so I'm going to pass it out to you now. And have a wonderful weekend. Oops, wait, it might not be weekend next time.